So we're now recording. So welcome everyone. My name is Ken. I'm the general manager for Asia for Onyx. Before I introduce our host, I would like to request that all attendees please mute and turn off your video. And then we will be taking questions at the end of the presentation. It's my pleasure to introduce to you Dr. Max Derhut, who will be presenting today on the DeviceLink Plus solution and some things related to that. Okay, everyone, once again, would you please hit mute? Thank you. Great. So Max is the principal scientist at Onyx Graphics. He's received a PhD in color science from Rochester Institute of Technology, where Max was instrumental in development and setting the international standard commonly known as ICC Max. Max is also the co-chair of the ICC and is actively engaged with other organizations, including ISO, CGATS, and CIE. Max has been with Onyx Graphics since 1990. He has received 10 US patents for his work and leads the product development engineering team and projects that are related to image processing, color management, as well as process control tools. At this time, welcome Max, and I'm going to pass over the control to Max here, and we'll let him get going.
You see that? Okay, today we're going to talk about device links and new dot patterns and stuff like that. And I want to start with the end, because that's really what we want to know here. Is basically if you can get anything out of this here presentation today, this is sort of the idea of it. It's really basically the generation of device links and ICC Max profile support. It was really introduced in Onyx 19, and what do they provide? They provide improved accuracy, consistent color workflows, and greater flexibility and control. And that's really the bottom line. So we're going to start off with that. Now, let's talk about device links. Now, in trying to describe device links and color management, this is a bit of a challenge because oftentimes, color management is it's black magic. It's voodoo science. There's these things called profiles, and they do stuff to make the color look good, and I don't understand how or why. And then somebody says, well, you want to use a device link profile, and okay, what's a device link profile? How does a device link profile differentiate from a color profile? So what I want to do is kind of talk about color management in simpler terms, or terms that people really understand. And actually, the people on this one will actually get into this a little bit more, because we're going to talk about currency exchange, money. Everybody understands money, or at least we hope everybody understands money. And basically, money represents value, right? And it represents your ability to buy something. And you can have different kinds of units. You can have dollars, you can have quarters, you can have nickels, you can have, various different kinds of denominations, and you can add them up together to get sort of some value. And then different places around the world, they have different different currencies. Okay. Now with color, it represents sort of a perception and how you make color. You can have different ways of describing and talking about color. You can talk about display spaces like Adobe RGB or sRGB. You can talk about printing with inks. You can have an ink that's on an offset press, or an ink that's in an inkjet. And then you can talk about color in terms of basically its perceptual aspects like lightness, chroma, and hue. And different color space units basically provide different ways of talking or describing about reproducing perceived color. Now, when we're talking about making conversions between denominations, that basically involves converting the monetary units of one denomination into monetary units of another denomination, And when we're talking about color spaces, when we're matching color from one device to another, well, there we're converting units of color from one color space to units of color of another color space. Now, one simple way of doing conversions, especially when your units are the same, would be is you just basically take the units that you actually have and reproduce them with the units that you want to go to. So, I could give you two fives and 10 Australian dollars, and I can convert that to two fives and 10 American dollars. And if I did that, I would be losing out because I'd be giving you something that's more than it's worth. And the same thing with CMYK. If you got the CMYK for a press, and we just basically take the units and take them straight through, that's one simple way of doing it. But for each of these cases, the printed results don't look the same, and the monetary unit doesn't have the same value. Okay, so doing simple conversion strategy doesn't work. What you really need to do is you need to have something that represents value and do the conversion relative to value. And so that's really basically what needs to be done. So in the monetary world, you have exchange rates. You have these tables that say, hey, I have a euro that's worth this much. I got a pound that's worth this much, and each one of those things is used, right? And for color, what we're going to basically do is we're going to use a measurement device that basically measures and gives a quantity relative to how we perceive color, okay? And then we're going to make the conversions relative to that value of color, or making in terms of monetary, you're going to make changes in terms of the perceived value. Now, when conversions are done, often in the financial world, there's basically a common exchange currency. And so you convert from, yen to dollars, and from dollars to pounds, or for dollars to euros, or, American dollars to Australian dollars. And if you want to add another currency, you just basically come up with the exchange rate between dollars and that currency, and then you convert from any currency to any other currency. And the same thing is done in color management. Basically, you have profiles that basically do a conversion between the device space, or the color, the units of the device. It would be RGB display units or ink amounts or whatever, to a reference color space, which is known as a profile connection space. Okay. Now, one a key thing about making these conversions is that basically for currency, it's really quite simple. You basically have a rate, and then you're going to have some sort of simple math that basically says, I'm going to take the amount for one currency, change this to the equation, and then this percentage, and then boom, I got the amount for the other currency. When we're making that kind of making conversions between color spaces with ICC color management, then what we do is we use a big old lookup table, and basically it has various combinations of the color units, and then for each one of those combinations, the corresponding one, and then you use some interpolative math to actually figure out what the intermediate values are. Okay. And so the one key thing is that transform itself potentially is not straight math. There's a little bit of guessing in between there. And so what happens is that basically we actually end up with fees that are transactional fees. People understand transactional fees in some cases for the exchange of currency. That transactional fee is basically how the person who's making the exchange is making money. And there's a fee for every time you make an exchange. And really, basically, the whole idea with making transforms with color management is there's a fee, but the fee is not in terms of a monetary cost. The fee is really basically a result of accuracy or error in the conversion. Okay, and the more times you make those conversions, you have greater error. Now, one of the places where we have the largest amount of error is when you actually go. When you go from the PCS to the device, there's a little bit more error. So the transactional fee going from the device to PCS is fairly low, but the transactional fee going from the PCS to the device is fairly high. Now, you can basically use a round trip where you basically go from one to another and then back. I mean, this right here is an example of you go to a country, you get the exchange for that other country, you don't spend any of the money of the country and you come back and then you try to exchange it back and you don't end up getting generally what you started off with unless the exchange rates changed while you were gone. Uh, and when we're talking about color management, if you basically look at a profile, you could basically kind of round trip going from the device to the PCS and then back to the device, and see how close you get back to the original color units. Now, because there's a cost at every step, what we could do is we could basically just reduce the number of steps. Rather than going from yen to dollars to euros, why don't we go from yen to euros? We come up with an exchange for that, and then we don't necessarily have to have as big of a fee because we haven't done it twice. And you can do the same thing with color management. And so the real distinction between a device link profile and an ICC profile is basically a device link profile makes that conversion from one device space to another device space without going into an intermediate PCS. You basically have a transform specifically for that. And this results in improved accuracy because we basically eliminated the fee of going from the PCS to the device space. So that's what now that you kind of understand sort of what a device link is. A device link is something that basically allows us to go from one device space to another device space directly without going into an intermediate into the intermediate PCS, giving us a little bit better accuracy. Now, how to use device links, okay, in the Onyx software. We spend a lot of time and effort to try to make the use of device links to get basically a little bit more accuracy in terms of applying the transforms. You're still applying the same transforms. We're just basically reducing the fees. And so you can do it in a number of ways. You can either go into profile setup and you can select your profile, either an image profile or a simulation profile. If we select a profile, then once the profile is selected, then we have an additional control in version 19 that basically allows you to do device link setup. And when you click that thing, it'll bring up a dialog to allow you to choose whether or not you want to have device links. You can either have no device link, you can specify that you want to have an automatically generated device link, or if you have some third party that actually allows you to develop device links, you can basically select that and use that. I'm going to talk about the auto creation of device links. And really the idea here is basically we've tried to make it so that the use of device links is basically simple and non-intrusive as possible. And so what happens is that basically you say, I want to use a device link. And then at the point where we need to actually do a transformation for processing, going from one device to the other device, we will then create a device link and then use that device link to actually do the processing. And the key aspect of it is when we create that device link, we'll cache it so the next time you go around to do something and you want to use that combination again, it'll reuse it without necessarily having to rebuild it. So it reduces the overhead of using device links. Now, once we've actually said we want to have auto device link, then all you got to do is push OK, and boom, you're using device links. And so that's all there is to it. It'll basically go from the CGATS CRPC1 profile to the printer, the profile associated with the print mode, and it creates a device link, and it'll use it. That we're done. But another aspect of using device links is one of the key aspects of creating a device link itself is basically what it's doing is it's basically taking the knowledge of the input profile and the knowledge of the output profile and building those transformations. And in doing those building of those transforms, we have the ability to essentially override some of the options that were used to build the printer profile. We can basically say, hey, I like to change the black generation, or I could change the gamut mapping, or I can make it so that it's more saturated, and various other options. Once you've selected the auto device link options and you turn on the use custom build options, then you do the device link build options, and then you can set those options. Now we're setting these options for this profile, for the profile usage. In a quick set, you could potentially set the black generation for CMYK images different from different from CMYK graphics, or different from RGB images. And each one of those could potentially have different black generation. Or you could have a quick set that says, I want a quick set that has, high ink usage, or a quick set that has low ink usage, and you don't have to go into the printer profile and rebuild and change the options of the printer profile. You can basically do it as part of setting up device links. If you have a RGB Contone printer, you don't have the option of actually doing anything about the black generation, because we're not sending any information about black to the printer, and in those cases we still only have the ability to adjust the gamut mapping and various aspects of saturation. Once the device link profile has been set up, then when you in Job Editor here, in this instance right here, next to the Change Profiles dialog, there's a little button that'll say, hey, I have a device link. I have a link defined here. And this tells us basically that for some aspects of our profiles, device links have been enabled. If you click that button, then it will actually go through the process of building the device link at this time. If you don't, then it'll basically use the profiles for the purpose of the preview. But when it goes to process, then it will actually do the creation of the device link if it doesn't already exist. Profiles that go from an input profile directly to a printer profile, the device links get cached as part of the print mode. And so when you export a media, all of the device link profiles that are associated with that, with the print modes, become part of that print inst, and then they can be transferred and used by others who are using or importing those medias. Forcing the build is possible, but it's not necessarily required. So we understand what device link profiles are. We understand the simplicity of trying to actually use device link profiles in the software. Well, what does it really do? And let's try to understand really basically. So what we're going to do is we're going to consider a round trip situation where we're going to have a CMYK profile, and it's being applied as both the input and output profile, which means it's basically been imported and being used as the profile associated with the print mode. Okay, and then what we're going to do is we're going to compare doing a round trip of two color combinations, and those are going to be colors that basically don't have anything to do with black, and we're going to see how well you can go from a CMY to a CMY and a round trip. This here kind of shows basically combinations of where we have cyan with some combination of magenta or yellow. You have magenta and some combination of cyan or yellow and some combination of cyan and yellow. And we're just going to basically look at how well we preserve the amount of cyan. So when you print with cyan, if you're using a profile going to PCS and back to the profile, what'll happen is that there's variability. Right here, it'd be basically you get the cyan you started off with, but there's actually variability, and you can see that the variability actually ranges between plus and minus 2 units, and actually getting really high as almost 6 or 7 units by just round tripping the profile. Same thing with magenta, and the same thing with yellow. Now, if we do the exact same thing, we're basically going from CMYK to CMYK with an auto-generated device link, then the variability is much, much smaller here, basically ranging somewhere around the area of 0, and actually for the most part, it's within 1 unit of the starting value. So the real key take home here is basically using device links. In this case, we have a smaller round trip difference, and when you're using device links, we have less error. Um, Now, why would we even care? I mean, we're talking about one or two or three different units, but the real thing is that when we're talking about positions where you're actually trying to ask for 100% cyan and you round trip and you end up getting with 96% cyan, that's a significant percentage because in those areas there's potentially a lot of ink due to the calibration that changes, and it can change the saturation very significantly in the high regions. And so these errors are most pronounced when you're talking about colors that are near the gamut surface or the most saturated colors. So using the device link basically allows you to basically get more saturated results using color management, where some people actually in some cases will turn off color management because they don't want to lose that saturation. Okay, so let's talk a little bit about the case in here. The device link plus benefits include basically when you create custom device link build options, let's go back up here. You can create device link build options to allow quick-set based gamut mapping and ink separation, which I mentioned. This basically utilizes the auto build and caching of the device link profiles. There's improved accuracy since there's no PCS interpolation being performed, and we can leverage the direct device-to-device knowledge when we're actually going from, you know, a white to the printer profile doesn't know what the source colors are because all it knows is the PCS going in. When you have a device link, you can start with an RGB 000, know it's a black and do something. Or you can start with an RGB 255, 255 chip drive and know what you're doing. Or you can have black ink only and do something appropriately. So the real key is with device links, since you actually know both sides of the transformation, you can leverage that to actually do more clever things. So we've talked about what a device link is and really basically and how they're used in the software and showed sort of some of the results with it. Let's talk about consistent color using device links. And really the key here is what we're doing is we're going to leverage two technologies to actually get stuff. We're going to do consistent color and device links. Now, getting consistent color. How do we go about doing that? Well, let's think about how color management works. With the input profile, it determines how the source color looks. It says this color, that this RGB value is this color. This CMYK is this color. That's what the input profile does. It's just basically saying what is the color. The output profile, it determines really how the color is going to be reproduced. Okay. And this involves essentially, it involves the inks that you actually have to print with. It talks about the gamut mapping, the color rendering, what ink separation you want to use. All sorts of different things are being done with the output profile. And so if we want to get consistent results, we really want to get consistent output. So what we really want is we want to basically get consistent color by making the reproduction more consistent. One way of doing this is basically using the same simulation proofing profile, which will basically define a single initial gamut mapping and color rendering, okay, and a single color space to actually map to. Now, the final ink separation is being performed by the print mode output profile, but the real key here is we're going to go into an intermediate state. Now, let me explain that just a little bit. So, in terms of using simulation and proofing profiles. And really what happens is basically we end up with two stages. Okay? The first stage is basically going to go from the input profile to the simulation proofing profile. Okay, we're going to basically use the transformation going from one to the next. Okay, and this may be as a device link, or it may actually be done as just two profiles going through a PCS. And what this ends up doing is it ends up basically converting all the colors into that color space associated with the simulation proofing profile. And this is where transparency and overprint and all that fun stuff are done in terms of drawing onto the page. Okay, we draw on the page, get the page all drawn. Then what we do is we then take those rendered pages and we're going to color manage from the CMYK simulation proofing profile, and then we're going to go to the output space associated with the print mode. Now, the simulation proofing space and the output don't have to be the same space. They could be, the intermediate one could be an RGB space. The intermediate could be a CMYK space. The output could be any space that you could actually go to in terms of the printer. But really, the key here is we're actually doing these two stages. Now, let's look at sort of what's going on internally in terms of using those two spaces. And when we can look at it in terms of color gamuts. Now, you have an input profile, and the one that I'm actually displaying here is for an Adobe sRGB display. It's got a really big, bright gamut, okay? You can see basically the shadow of that gamut down here and see how big that is. And then you can compare that going to a printer profile that actually has a smaller gamut. It has a very, very light black, and it doesn't really necessarily get very saturated. And so those going to be different from each other. And then what happens when we're doing color management is basically you're going to have the input profile define where you want the color, and then the output profile, it's basically saying, okay, for all these colors here, and you can see the colors internally, we're not really doing much to those, but outside, we're actually mapping those colors in there. And the direction you map it and stuff like that, that's gamut mapping. And if you basically add some contrast to things, that's rendering. But really, basically, it's really the output profile that's doing all of that fun stuff. Now, if we look at different output profiles, you can have different gamut mapping strategies, the shape of even with the same gamut mapping strategy, colors that are way out there will potentially move to different places depending on where they're at, rather than like for here, it's going up to there, but here it's going over there. You can see that there's variations. And so the variations of the output from printer to printer and print mode to print mode is largely due to the fact that the shape of the gamut's different, or potentially the rendering intent. The gamut mapping strategy is different. And so getting consistent color when I'm going to all these different printers, well, every printer, the print mode, the profile associated with the print mode is making lots of decisions. And any one of those decisions being different ends up getting different, largely different results. Okay. So what we want to do is we get more consistent results by doing things in two steps. So first of all, using that simulation profile maps to a common space. So we're mapping all of these colors way out here into something that's a print space, and it may actually be a large gamut here. And then what we do is we're going to map from that large thing to the little thing. And since we've done most of the heavy lifting to get to the gamut of the intermediate space, the changes that are needed to go from there are not necessarily as large. So what happens is that we basically end up getting more similar results because we've basically done that first large stuff of the rendering to get from an RGB like space to a print space, and we're doing it in a common way. And if you have smaller spaces, then we're going to do some additional mapping here, but it's still necessarily going to be much more similar than if you actually just went directly to that output space. So how is this configured? Well, we're going to be basically setting up a profile for the consistency simulation profile, okay? And we'll specify that. Now, if you really want to get some of the best output, the output that actually has the most saturated, using most of the gamut. If you have printers that have really big gamuts, then having a simulation profile that's really large ends up getting basically results that utilize the most of the printer without necessarily sacrificing gamut. And there's various large profiles that you can select from. The ECI CMYK Fogo 53 profile. This one here is essentially got the same gamut shape as the Color Master system used in Europe. The CGATS 21 CRP7 has a really large gamut that uses a G7 grayscale, and then the Onyx, the PRM G13, it's got a really large gamut that is equal to the perceptual reference median gamut defined by the ICC. These are really big gamuts. Now, if you want to use smaller gamuts, now smaller gamuts actually have a good use. And by using a smaller gamut, what happens is you get much more consistent results because they're likely to be inside of the or closer to the size of the gamut, inside or close to the size of the gamut that you're printing with, and so you get more consistent results. You're going to have a challenge of getting consistent results if you're basically going to a space that's really much larger than your printers, because then you end up still having that variability of the different printer gamut mapping. I do not recommend that people basically use a profile for a print mode as an intermediate. That's going to generally give you you're not going to be happy with the results because the inks of the printers are going to be different, and you're not going to get exactly the same. Saying I want to make everything look like this printer, it's a challenge. It's better to try to go for, I'm trying to get all these printers to match basically a standard look that's defined by a profile, and that standard look is achievable or within a short distance of what you're actually printing to. Now, this is how you get consistent color, is by basically setting that profile. Now, if we basically use a simulation profile, we actually do two steps. The first step is going to go from the input profile to the simulation profile, and then from the simulation profile to the printer profile. So if we're just basically using profiles, we're going into and out of PCS twice. Okay, so we've basically doubled the transfer fee for converting colors. Okay, if you basically select a device link profile for consistency profile, then this reduces the transfer fee of that second conversion, and so it's basically going to have essentially the same conversion error as just going directly to a printer profile without using device links. In addition to actually setting up the profile, you also need to basically specify the rendering intent. I recommend that people use the relative color metric with black point compensation. This is not trying to get a proof. This is trying to get more similar color. And it's not going to be exact, because if I go from one printer to another printer, the medias will be different. You really want to have white stay white, and so relative color metric allows the white point to be preserved, and with black point compensation allows the darkest blacks to be consistently achieved. So it's not going to be the same as a proof, but you'll get more consistent results, and that's really the goal for doing all this. Now, once you've actually set up your profiles, then if you click on the little button next to the change profiles, you'll have the ability to save that configuration. So if you set up all your profiles, you set up your how you want to use device links, and all of that fun stuff, then once you're done, you can save that, and then that becomes a color management setting that can then be easily selected again when you're selecting profiles. You have all profiles on. I will now have, once I'm done with this, the ability to select consistent color wide gamut. So it makes it very easy for me to then use that. In addition to that, I can also then use it in your quick sets and actually save and do your processing so that it uses the color management the way you intend to have it. Now, do need to talk a little bit about sort of how this using simulation profiles works in terms of PDFX and version 2 PDF. Both of these have what is known as an output intent profile that can basically define the target output profile. So a designer will say, I want to use US web-coded swap, and that's the target I'm going to, or I want to be able to use Fogra 39, and that's my target, or Japan color. And the document is basically intended to be printed on that, and so that's the color management you have. Now, if you turn on a simulation or proofing profile, and you have an output intent profile in a PDFX file, it will use the PDF, the profile in the output intent as the simulation proofing profile, okay? Which is really nice, because that means that you get basically consistent results relative to the intent of the PDF. Now, there is a setting inside the configure IPS, which is use embedded output intent, which is basically set up to say use the embedded output intent profile for proofing. Now, if you don't turn on the simulation profile, the output intent profile is completely ignored. Okay, if you turn on the simulation profile, if this particular setting is not checked, then the output intent profile is selected. If this setting is checked, then the profile that you put into the simulation will be used. So if you have my big gamut, sorry, my headset after about 30 minutes decides to shut down on me. If you're using my big gamut profile as your simulation profile, and you use a PDF that has the, some offset profile, then what will happen is that it will use the small press profile gamut to do as your intermediate, unless you check this button. Okay, and so that's really key. By default, we use this. But if you're wanting to get similar results that have wide gamut, you need to go in and turn this off, either for the system or for the job in the quick set. Okay, another aspect about using consistent simulation and proofing profiles, and that is with name color spot replacement. Name color spot replacement always goes directly to the color space defined by the print mode. So if I have a CMYK OG space, then I have Pantone 407. Pantone 407 will use the color management going directly to the print space. It won't convert from Pantone 407 to the simulation space and then from that simulation space out. Because people generally, they want to get the most accurate reproduction of the colors using whatever they have in the printer. It's kind of like using spot colors in a press. You want to use the spot color, not the CMYK, and so that's what it does. Now, consistent simulation profile is not used for those, and if you tried to do so, there's some problems with that, because basically this invalidates the print mode based spot replacement as job based spot replacements. When you specify spot colors in the spot color settings, there's a tab for print mode spot colors where you can specify this is the CMYK orange green that I want to use. Okay, and if you're using a consistent simulation, it would go to CMYK and it doesn't match that, and so you would basically have to ignore the colors you specified for the print mode. Okay, and that's okay. So device links and consistent colors. Okay, using device link is really not necessary, but it does improve consistent color workflow. Okay, colors generally the same with or without the device link. Because we're talking about differences of a few percentages of ink. Is really the difference. However, device links makes the results more accurate and saturated. Okay, which is something you may want to do when you're actually doing this. Device link should probably apply to a simulation profile, and once it's built, then the device link goes into the MediaDB and it's part of the exported OML. You can also apply device links to the input profiles, and when you do that, since you're actually going from essentially an input profile to another input profile, those profiles get cached in what's known as the auto link folder in Onyx profiles. One caveat with all of this is that the device link is not going to be applied when embedded profiles are used. So if you have an image that has an embedded profile and the profile settings say use embedded profile, it uses that profile and goes from that profile to the printer profile or the simulation profile, whatever it is, without using a device link, because we don't necessarily build and cache profiles that are associated inside of image. They're kind of a temporary thing. Okay, so enough about device link. Let's talk a little bit about something else new that's exciting in version 19. Spent a lot of time on this, and a lot of this time on this for actually the people in Asia and the Pacific region. And there was a lot of people were some people were complaining about the dot patterns. Some of the aspects of the dot patterns were is they kind of got clumpy, they weren't smooth, um, potentially resulting in banding on printers. And so we spent some time developing 3 new dot patterns. Um, that are now part of the version 19 software. And they are enhanced stochastics, line stochastic, and screen stochastic. Each 3 of these dot patterns are selectable when you're creating new print modes in Media Manager. They can't be used by earlier versions of the software. So if you profile in version 19 using this and create an OML and try to use it in version 12, it won't work because version 12 doesn't know anything about these dot patterns. Okay, all these dot patterns have similar processing overhead as the legacy stochastic dot pattern. Um, they just look better, but they process basically internally on the hood the same. So let's talk about the first dot pattern. The first dot pattern is basically enhanced stochastic. And really this right here, first of all, it correlates where dots are for cyan, magenta, and black. So cyan dots don't end up on top of black dots, and they don't end up on top of magenta dots. They're separate from each other. And when you're using combinations of that, really means you end up with a more solid fill, and it looks less grainy. Okay. The second thing about it is that basically we have a larger screen size, so that the actual pattern duplication happens less often, and it's also been changed to avoid harmonic frequencies with printers to reduce print banding. Okay, and another thing is that the algorithms were developed to reduce blotchiness. That was some aspects where some places it was just a little bit more dense, and other places it was a little bit lighter, and try to be a little bit more consistent across for the dot patterns. Okay. The second dot pattern basically takes the enhanced stochastic dot pattern, but we're going to make a change to the blacks. And what we're going to do is we're going to basically make the blacks so that they basically kind of fall on a 45-degree lines, and they actually form lines. And the result of this is you get very, very, very smooth quarter, mid-tone, and three-quarter tone scales because you basically have, these lines that are actually filling in. And what happened, and the reason why this is actually important for the black is basically a lot of the detail and structure of images is actually primarily determined by the black ink. So if we make the black ink smoother, we actually can potentially overall smooth out stuff without necessarily sacrificing some of the detail. One of the things of doing this is it kind of mushes things a little bit too. And then the third dot pattern basically is doing sort of the same thing that we did with the black, but we're going to do it also to the cyan and magenta. So we actually have the cyan resulting in an 18-degree angle and the magenta at a 72-degree angle, and combining them. And so you basically got a stochastic screen half rosettes. It's kind of an interesting dot pattern. And the one thing with the line patterns is the line patterns end up being a lot smoother for solid fill. So if you're doing things like textiles and stuff like that with a solid fill, they can be smoother. One of the contrary channels is that potentially smoother dot patterns can pull out problems with the printing, it can actually accentuate issues in printing, like banding and stuff like that. So these dot patterns are not necessarily a panacea for every possible combination, but they're now available in version 19. And at this point, I really don't think that there's really a need to people to use the legacy dot pattern. If you're creating you're profiling a new print mode, use the new dot pattern because it'll get better looking results. This right here is a comparison of the different dot patterns side by side. What you want to do is you want to back up from your display just a little bit so that you can to the point where you're not seeing the actual patterns, and then you can start to see the smoothness of them and how that smoothness changes for the different methods of placing the dots. To get to these dot patterns, when you're in Media Manager, you have to basically get to them from Media Manager. So yeah, in Media Manager, you'll click on Configure Devices, and then you'll configure the printer capabilities, and then you will click on the dot pattern section, and then you'll see the screen stochastic, line stochastic, and enhanced stochastic as options. If you're doing this on a printer that doesn't have any of those, then they will not show up. Once you click on those, then they'll be available in the when you're going in and building the creating new print modes. Okay, so let's wrap up here. In summary, device link profiles, they provide greater accuracy, flexibility, and control. Okay, that's really the whole purpose of using device link. Now, consistent color is achieved by using color simulation and proofing profiles. And when we combine those with device link profiles, we get more accurate results and while getting more consistent colors. And the legacy dot pattern, the new dot pattern itself provide for better output and the same performance as stochastic, legacy stochastic. And all this is available in version 19 and beyond. So how do you get to these? Well, they come standard with version 19 products, okay? And existing customers, they can upgrade to 19 to access them, and the new the device link and the new dot patterns, you can do that through an Onyx Advantage subscription. If you're a new customer, you can obtain 19 through a new license purchase. And if you want more information about this, we recommend that you contact your authorized Onyx reseller or email someone at Onyx. And that's all I have. Any questions?
Yeah, if I could, Max, it's Tom here from Australia.
Good to hear from you, Tom.
Thank you. Thanks for your presentation. I like the money reference. That makes it easy to understand.
That's good.
My question is, could you give us an example of how you would set up a device link to, like, let's say I've got two printers. I've got a small printer and a very large printer, and I want them to print the same. What sort of workflow, what other steps, or do you have to do any other steps other than what you've shown us?
No, that's what I would show you. I would pick an intermediate color space that does things that you want. One of the input profiles would do. If you want to get the largest possible gamut, then you may want to use a larger one. If you use a smaller gamut, you'll get consistent results. Most printing is being done to something like Fogra 39. Most printing is being done to that or a space like that. And so picking one of those gives you basically reasonably good color for anything that's using color management. And you still get your spot colors, and that'll give you really similar color between those printers. However, you may not necessarily be using all of the gamut in all of the printers. And so, but since it's smaller, you're using less ink. So, the rule in trying to get things more similar, are you trying to conserve media, conserve ink? Are you trying to get the most you can out of the printers? The larger you get, the more variability you potentially have between the printers. Really, I can't tell you exactly what you need to do because I don't know what you want to accomplish. I mean, that was really why I gave those two things. Is basically I would use either one of the larger gamut. Probably the ECI Fogra 53. That's probably a good one to choose for large gamut stuff. And then for smaller ones would be your favorite press profile, whether it be Fogra 39, ISO gamut, or Japan color, depending where you're at.
Sure. I guess what I'm trying to understand is I'll have one profile that's created on let's say the Latex 360, and then I'll have a different profile that's been created on the big Latex 3100. Do I just switch on device link for both of those profiles, and then if I'm printing the same job, do I just send one to this machine and one to the other, and that's all you need to do?
Yes, you need to actually set up to use you have to set up your jobs. I would set up the quick set to actually have the same simulation profile on all the printers. And that's really the key is you're setting the same simulation profile on all the printers. So you're basically using the same gamut mapping for all the printers. Okay.
Okay.
That's where we're getting the same color, right?
Okay, I'm with you now. Yeah.
Even though all the printers themselves have different profiles, since we're going to the same simulation profile, that's where we get our consistent results.
Okay. I understand now. Thank you.
We're not going to try to make printer 2 look like printer 1. We're going to try to like all the printers look the same in their final results.
Sure. And does that, like, let's say you've got a 10 color machine and a 6 color machine, does that then dull that 10 color machine, obviously down to the capabilities of the 6 color machine?
It basically dials it to whatever it is you have. So if you have a smaller gamut, you're going to get more consistent results between them, and the large, 10 color is going to get dulled down. If you use a larger profile, the larger profile will potentially keep more of the color, and you're going to still get some differences, but a lot of the difference is really that initial gamut, especially it's really the biggest difference for RGB images. RGB images actually end up getting really super affected by the gamut mapping. So if you actually have that simulation profile that does that initial gamut mapping, even going from between a large and a small gamut printer, you're going to get more consistent results between them for RGB images.
Sure. Okay. Oh, that's really good. Thank you.
Okay. Anyone else?
Mark from Australia. Hi, Max.
Hi there.
What about, I thought that the simulation proofing would trickle more into absolute colorimetric. Is there a way if I want to simulate stock colors?
Is there a way?
So like a proofing setup? I've got a GMG setup and I can print like a base color that simulates the other printing process. Is there a way to do that?
Yes. What you do is you turn off spot color replacement.
Spot colors. But this is across like a whole image. It would.
If you turn off name color replacement, that's what you're doing is you're going to the process color space, and you're actually then rendering that to the intermediate space.
So then what comes out of my output would have a simulated paper.
Well, this is not necessarily. This is not. I mean, I'm using the consistent color, not the proofing. Okay. In my recommendations, I'm saying using relative intent. So we're not trying to. I'm not trying to try to simulate the paper. I'm only basically letting the gamut mapping be essentially the same with relative matching. So the real key here is there's a difference between getting an exact match and more similar color. And that's really the goal here is more similar color, because an exact match usually ends up getting dirt, you got scum dots in your whites and all sorts of things like that, which not necessarily, I mean, if you want an exact proof, that's proofing. But for this right here, it's more of people doing printing, but they just really want to have the output on all their printers to be more similar. So that's what we're doing.
Okay. Thank you.
Hey, Max. Michael Pruitt in the U.S.
Hi there.
Hey. Question for you. When you have, you're using device links and you have a PDF source file that you're printing that has multiple embedded elements with different color spaces, is it generating a different dynamic device link for each of those connections?
For embedded profiles, device links are not generated. And so in general, but if you use a simulation profile, you can basically use a simulation profile and then have the simulation to the printer profile be used, and then the input profiles wouldn't. And actually,
normal colored versions would happen between the different color spaces between there and the simulation space, and then there's just one device link between simulation and output.
yes. And generally, in terms of printing in the press world, that's what they do. They basically create a device link for that between that basically the intermediate color space and the printer, so that you're getting exactly what you want to do.
Okay. All right. Thanks.
You're welcome. Okay, well, I'm going to turn it back to the host. If you're speaking, I can't hear you.
Oops, let's try that again. So, thank you very much, Max, for your time, and thank you everyone for participating and for your questions. We will be hosting 2 more rounds with Max over the first half of May. You can, you should have the links in the emails you've received. You can also go to the training page on the website to register and sign up. We also have a ton of other webinars going on in the US and Europe that you can see links to on that site. And just tremendous amount of free training going on from April through the month of May. So I do encourage you to get your technical people to participate. Most of you are working from home. So a great opportunity if you can take advantage of it. Any further questions or very detailed stuff, feel free to reach out to us back in email, and we can follow up with you further to help you with your needs on some of these new functions. And that will conclude the meeting for today. Thank you so much again, and everyone have a safe and healthy rest of the day.
Thank you.
Thank you.
Thank you.
Will this recording be available to us later?
Will we what?
Will the recording be available to everyone who attended this presentation?
I'm not sure how that's exactly accessible, but just email me and I will get that to you if they give it to me. No problem.
Okay, thanks.
Okay. Thank you again, everybody.